In this video, we're going to look at how we could compare compound interest accounts that have different interest rates or different compounding periods or both. So how are we able to judge which one might be the best combination? So to do that, what we're going to use is something called annual percentage yield, or sometimes known as effective rate, to compare accounts. So they use the notation APY. Okay, this is one thing. So it's not A times P times Y. I know the other formulas make it seem that way, but it's just one thing. And what it is it's the simple interest rate that would result in the same amount of money in a year. Maybe I'll say one. Okay, so in 1 year, as whatever compound interest account you're looking at. Okay, so it's after 1 year. Okay, it's going to give you, so this rate in simple interest would give you the same amount after 1 year. Okay, so how do we determine the APY? So let's just remember the formulas. So for simple interest, A was P times 1 plus RT. Okay, and for compound interest, A is P times 1 plus I to the N. So what we want, so we have our compound interest account, which again, I guess we could write this using R's. Okay, so like that. So what we want is so the APY is this R. Okay, so that the A value here is the same as the A value here. Okay, so what this is going to look like is it's going to be P times 1 plus, so APY is one thing, okay, times T, but the T is actually 1. Okay, so it's going to be times 1. Okay, so for APY, when we're finding it, we're using T equals 1. So it's P times 1 plus APY times 1. So this is the amount, the A in the simple interest using rate APY. We want that to be equal to the amount that we would have after 1 year in our compound interest account. Okay, so maybe let's just emphasize this. Okay, so this is the amount, maybe I should say the future value in simple interest account with R equals APY. Okay, and over here, this is the future value, and 1 year. Okay, this is the future value in our compound interest account in 1 year as well. So notice I put in T equals 1. So if we divide both sides by P, the P's are actually going to cancel. So what we end up getting is 1 plus APY is equal to 1 plus R over M to the power M. So if I solve for APY, just subtract 1 on both sides so that goes away. So APY is going to be 1 plus R over M to the power M minus 1. Okay, this is actually what we want. So that's the formula for a compound interest account. So if the principal invested at an annual interest rate R is compounded M times per year, then the annual percentage yield, so the thing that we use to compare, the APY, is going to be 1 plus R over M to the power M minus 1. Okay, now if you were using a continuously compounded interest rate, okay, it's going to look a bit different. So in that case, maybe I'll just do it over here. So I would have P times 1 plus APY times 1 is going to be equal to P e to the R times 1. So P's again cancel out like they did before. So I get 1 plus APY is equal to e to the R. So APY is going to be e to the R minus 1. Okay, when you have a continuously compounded interest account. So let's just do one example where we compare some accounts. So suppose you have 3 accounts available. So maybe let's just do them separately here. So account A. So let's write the information. So A pays an interest rate of 4.95%. So R is 0.0495. It's compounded daily. Okay, so M is 365. So then we would want to compute APY for A. So I'm going to write APY sub A. Okay, so this is for account A. So it's going to be 1 plus 0.0495 over 365 to the power 365 minus 1. And if you compute that, you get 0.050742. Okay, so oops, maybe I'll do there. So the simple interest rate yielding the same amount of money, so same money, the dollar sign, after 1 year is 5.0742%. Okay, so that's for account A. Now we do account B. Okay, so B has a slightly higher interest rate. Okay, so 4.97%. So R is 0.0497, but it's compounded quarterly, so it has a smaller M value. Okay, so then APY for B is going to be 1 plus 0.0497 over 4 to the power 4 minus 1. So if you compute that, you get 0.050634. Okay, so that's giving us a 5.0634 percentage. So far A is slightly higher APY value. So the percentage there is a little bit better. Okay, account C has a lower than both interest rate. Okay, so R is 0.0494, so slightly lower, but it's compounded continuously. So I'm going to write M goes to infinity to sort of note that. Okay, so that's what I mean continuous. So we use the special APY value. So APYC is going to be E to the 0.0494 minus 1. Okay, and if you get that, if you compute that, maybe I'll move down actually. So it's going to be 0.050645, something like that. Okay, so this is 5.06405%. So we would conclude, account C is slightly better than account B, even though B has the highest interest rate. The compounding periods sort of make up for it. So it's better than account B, but account A actually has the highest one, so It has a lot of compounding periods, and the interest is one of the higher ones anyway. So we would conclude that account A has the highest APY value. Okay, so that means that it has the most money after 1 year. So we probably want to invest there. Okay, so when you want to compare accounts, you want to compute the APY value to compare, because this will combine the sort of compounding periods and the interest rate that you have.